solar, activate, falcon, plastic, silver, stripe, and type of 3 flow. And the Pixie has our NDC code igniting the MP radio. Raphael, boom, boom, waffle, and tornado, Jacko, cherry pie, and WSGI, glass, hammer, web, sphere, red beam, turbo gears, albatross, aquarium, selenium, web pie. Sidecar, tapestry, maverick, and JSP, barracuda, Akarama, groovy on grails, intercal on interstate, cascade and hibernate, JD, BBC, ruby on rails, jasmine, doctrine, Java forms, engine, active record, D3, dapper and velocity, time leaf, top link, pyramid, rethink, aura, Rico, Midori, and Mojito. Site mesh, Cymbeline, Enterprise, Java Beast, Hub, Graph, Boost, Click, anything by Telerik, Rango, Dojo, LLVO, Genpro, Carbonado, Seaside, Pylons, and Peroxide. Fuse box, flight flex, service stack, Silex, Carbon, Coco, Amble, Giotto, Banshee, Symphony, Laravel, Fat Free, Macapeca, Hobo, Cuba, and Rialto. Open ReST and Nancy, ASP, NDC, Kendo, Zep, OTBC, and Tempo, Java server faces, entity spaces, Cappuccino, Spec Flow, Polymer, JDO, Google Web Toolkit, no need to learn JavaScript, JDK, code away, what else do I have to say? Type boilerplate, jQuery, animate, mustache, tempo, ionic, and Allegro, bootstrap, backbone, running on an iPhone, mobile app, going live, built-in HTML5, Angular, Spectaculous, React, Redux, Knockout, Ember, does anyone remember? Just like in the browser wars, I explore and Netscape 4, Lodash versus underscore, and I can take it anymore.
Good afternoon, NDC. Everybody stand up. All right. So remain standing if you build or have ever built APIs that use HTTP. So if you've never built any web services at all, sit down. Okay. Remain standing if you've ever implemented server support for HTTP put. Remain standing if you've implemented patch. Remain standing if you've ever used content negotiation to avoid something that would have been a breaking change and upset your customers. Congratulations, you people are the lucky winners. I'll buy you a drink later. Hello, yes, welcome. My name is Dylan Beattie, and for the next hour, I am going to talk to you about REST. So, little exercise there at the beginning just to get some idea of, the level of the room and who's done what and stuff. And, it's pretty good. Most of you clearly, you understand the principles of HTTP. You understand some of the patterns. You understand what patch is, even if you've not necessarily worked with it and stuff. REST is a massive buzzword. REST is very, very widely used. Hands up anybody who has ever talk to a vendor and they've gone, oh yeah, we have a RESTful API. And you look at it and you're like, no, you really don't. You think you do, but yeah. So what we're going to do this afternoon is I'm going to take you through some of the sort of the bits of REST that go beyond just HTTP get and post and put, and actually look at some of the architectural constraints and the styles which create or which inform the design of RESTful systems. REST is not necessarily good. There can be RESTful systems which are bad systems, and there are systems which are very, very good systems which have nothing to do with REST. One of the key things to understand, one of the things that I try and do with these talks is to make sure at least people understand what we mean by what is a RESTful API and what is not. There is no intrinsic value judgment in whether REST is the right thing for you, for your team, for your company, for what you are trying to achieve, your customers. But if we don't understand the distinction between RESTful systems and other systems, you can't have an informed discussion about it, you can't make an informed decision about it. Very quick recap. This is Roy Fielding. Roy Fielding was at CERN. Roy Fielding worked on the HTTP 1.1 spec. Roy Fielding worked on the original HTTPD and Apache web servers. He's now the chief scientist at Adobe. And REST was an architectural style that was published in his PhD thesis. As PhD theses go, it is actually very readable. It's on his website. I thoroughly recommend, if you're interested in understanding where these ideas came from and the kind of rationale and the thinking behind them, check it out, read it. It's good. There's some really, really good stuff, good reasoning, good examples, good discussion in there. And what he basically says is this: when given a name, a coordinated set of architectural constraints becomes a style. Roy Fielding's thinking was very heavily informed by architecture in the sense of construction, buildings. Walking around downtown Sydney yesterday, there is some astonishing, wonderful architecture here. And in architecture, we have styles. You have Rococo, you have Baroque, you have Brutalism, you have Classical, you have all these things. And they are not tools, and they are not frameworks, and they are not plugins, and they are not modules. They are styles. It is a set of patterns for thinking about how to solve certain recurring problems. REST is not something that you download and install from NPM or NuGet. REST is a way of thinking about how the systems you are building are going to evolve over time. And this is one of the key things to bear in mind about it. This is a direct quote from the person who coined REST, and he says, "REST is software design on a scale of decades. Every detail is intended to promote software longevity and independent evolution. Many of the constraints are directly opposed to short-term efficiency. If you are in a hurry, if you are trying to ship version 1 before you run out of funding, if you are trying to hit a deadline, if you are trying to fix an urgent problem that is happening in production, you should probably not be trying to build a RESTful system. Those are not the situations where REST is the right answer to your problem." The other thing about this, it's on a scale of decades. Roy Fielding published his PhD thesis 15 years ago. We have not had decades yet. We've had 1.5 decades. That's not long enough, really, to know whether he was right. But there is a lot of thinking that suggests that many of the patterns that he outlined they are good ways of building flexible software which can evolve over a long, long period of time. REST is about trying to design systems which will run for decades. Anyone here actually got code they're running that's more than 10 years old? I know I do. Go classic ASP, the framework that never dies. But it's this interesting. Think about what it is that you're doing. What is the value you're trying to deliver? You're trying to delight a customer? Are you trying to hit a deadline? Are you trying to comply with some new legislation? And if those requirements genuinely inform building a system which you want to be able to evolve over, not necessarily decades, but years, then it's worth really taking the time to understand these patterns, and then making an informed decision as to whether they are the right patterns for what you are trying to do. REST outlines a set of constraints around how software systems are built. It's interesting to note that REST does not say you must use HTTP. It doesn't say you must use XML. It doesn't say you must use JSON. It defines a set of patterns for communications between a client and a server and ways of facilitating those interactions and those conversations. Client-server should not be terribly surprising to anybody in this room. You have a client or lots of clients. We've probably all got them in our pockets. These things are clients. Some of these things are servers as well because they're getting quite clever now. But you have a server which has centralized data, logic, behavior, rules, information. You have a bunch of clients connecting to it. This helps in a lot of ways. If you need to fix something, you don't need to mail out CDs like everyone had to in the 1980s. You just go, bang, we've deployed a new release to our server, and now all of our customers got the benefit of that new release. Statelessness is one of the key tenets of being able to scale systems easily. It's also one of the things that everybody kind of got wrong almost as soon as the web was invented. Has anyone been through the process of taking something like ASP.NET or PHP and trying to put it behind a load balancer, and suddenly you realize that things are breaking because your code uses something called session? Yeah. So HTTP comes along, and REST is a set of styles on top of it, and they're like, oh, don't have state, you know. Every conversation between a client and a server should be an atomic transaction. The client should say, this is me, here are my credentials, here is all of the information that I need to give to you, and the server, the HTTP server in this context, should be able to say, okay, we can deal with that. The second you introduce session, you're relying on your web server to remember who was here a minute ago. You've got all these little half-finished conversations and half-baked transactions hanging around in memory. One, you could do better things with that memory. Two, you don't know whether anyone is ever going to come back and finish those conversations, so you have to think, well, do I want my session timeout to be set to an hour? Do I want my session timeout set to 5 minutes? And three, if one of your servers in your farm dies, you need to bounce someone onto another one, it's going to die because all of that state has disappeared with the server that has just gone down. So try and avoid state. You know, if you have session, your system's not RESTful. It might be a perfectly good system, you know. It might be the right solution to your problem, but it's not RESTful. Cacheable. Cacheability is particularly relevant out here in Australia, where there are 4 fiber optic cables connecting us to the rest of the world. In a perfect world, when they release a new version of jQuery, that will get downloaded to Australia once, and then will be cached locally. And everyone else in the entire nation of Australia who needs jQuery 2.1 will get the same one instead of reusing the very valuable contended bandwidth. Cacheability, there's basically 2 ways of caching that matter in RESTful systems. Infinite and never. Optimize for infinity. When you put a resource on the web, try, if you possibly can, to make sure that anyone who's ever seen that resource, that URL before, can use the version they got last week or last year, or the version that someone else got that their ISP is caching or their cellular data provider is caching. When you start thinking about it in terms of, oh, you know, cache for 3 hours, 6 hours, no, think about it never in infinity and optimize for infinity. It really starts to inform the way you think about the information you're presenting, how you structure your URLs. Layered system goes very, very closely hand in hand with cacheability. It's the idea you have a client and a server, and actually the client doesn't care whether it's talking to the server or it's talking to a proxy that's talking to a load balancer that's talking to a server, or it's talking to a proxy that's talking to something else, that's talking to a VPN, that's talking to a file, that's talking. At every level, any element in that stack should talk to the thing above and the thing below, and it shouldn't care what's hidden behind those. This allows you to do things like, so a good example of this is using reverse proxies on things like your build pipeline when you're downloading packages from NuGet or from NPM. Stick a proxy in front of it, and then if you've ever downloaded anything, you'll have a local copy of it. NuGet doesn't need to know that that's happened. Your build server doesn't need to know that that's happened. The upstream servers have no idea that you're caching stuff, because each of these layers provides an abstraction between the relying system and the providing system, the server. Code on demand is the ability to say, the servers, I got a whole bunch of stuff. I got logic, I've got data, I've got behavior. I'm assuming most of you were in Scott Hanselman's keynote this morning, where he's talking about, you know, this idea you've got 10 VMs running in a cluster and you've got 1,000 users. Now, actually, now you have 1,010 machines involved in your infrastructure because all of your clients have got machines of their own, which have computing power, they have memory, they have storage, they have capability. Code on demand is what makes this happen. Code on demand is why Gmail kicked Hotmail's ass so resoundingly, because Gmail came along and they're like, actually, we are not going to round trip every mouse click back to our server and send it back again. We're going to run your mail system on your computer, and we're only going to talk to the server when we actually need some information. We're not going to just use it as part of navigation. And that, code on demand is just JavaScript and the assembly language of the web. This thing has taken off massively in terms of browser experiences. There's not so much yet in terms of APIs. Most people are still quite wary of getting arbitrary code on an API response and then running it. I was installing Homebrew on my Mac yesterday, and it's like, paste this shell script into an administrator terminal window. And I'm like, no. I'm not entirely sure I want to do that, so you go and you dig the bits around. So there are elements of trust, and there's some security patterns we're going to look at later which facilitate these kinds of interactions. Uniform interface, anything you can do over HTTP, as an example of this, is done using the same thing. You have a verb, get, put, post, options, head, patch. You have a content type, you have a bunch of headers, you have a payload, body request, body response. It's the same for all of them. If you want to interact with a PNG or a piece of video or something, you do not need to switch to a different protocol and a different set of conventions. The same interface is used to interact with different media types being provided by different systems. It's one of the reasons the web works. One of the reasons why the web is better than you had the AOL client to get on the AOL network to talk to other AOL users. And if you wanted to talk to someone on CompuServe, you couldn't, because they were all these little walled gardens. And finally, the one which we're basically talking about for the rest of the day, hypermedia is the engine of application state, which I'm not going to explain now. We're going to talk about that in depth. This bit is optional. In the thesis in which REST is described, he explicitly says, code on demand is optional. That bit, you can do it or you can not do it. All of the rest of them, that's what REST is. If your system has these problems and it embraces these patterns and principles in order to solve them, you can legitimately say that you have a RESTful system. You don't necessarily need all of them. You may have very, very small systems where actually there's very little notion of application state, and so you haven't got hypermedia yet. But as your system grows and you start encountering the problems that we're going to look at today, if hypermedia is the solution you adopt, then you're RESTful. If hypermedia you decide is too complicated, then you're not RESTful. It doesn't matter. You might still be fine. System might work. Ship it, everyone gets paid, customers are delighted. REST is not magic. It's just one more way of doing things. And the more we understand about it, the better informed decisions we can make about whether it's the right solution for what we're doing. So, we're going to build a social network. And we're going to build a social network for superheroes. Because all the social networks that we've got at the moment are all based on the idea of people having friends. I want to build a social network where you can have enemies. So you can, assign people and you can have battles, and then we can sell the film rights for billions of dollars because, you think software's big bucks. Look at what Marvel are doing in Hollywood right now. So, and we're not interested in front-end stuff. We're just building a back-end. We're going to build a persistent system. We're going to put an API in front of it, and we're going to publish our API specification, and the world is going to come flocking to our doorstep, and is going to embrace our social network. And we're going to start with this. We're going to start with a endpoint, a resource called profiles. This is a collection of profiles, because you've got to have profiles, because it's a social network. And we are going to seed it with some test data, and the first person in our network is going to be Tony Stark, who has chosen the username Iron Man for obvious reasons. We've got some data. At this point, we've got a pretty good RESTful solution to an incredibly small problem that isn't actually very interesting. So let's extend it a little bit. Let's create a way that people can join our social network by posting their own data to our endpoint. So now we've got post/profiles. Hands up anyone who has ever argued with their team for more than, say, 4 hours about what HTTP post actually means. The rest of the verbs are pretty simple. Get me that. Put, replace that with this. Delete, remove that. Post is complicated because post can have side effects. Post can be used for things which are not idempotent, things that it might be safe to do once and dangerous to do twice. And so there's a lot of specific validation and semantics about the way you implement post. So all we've got here is we've got an endpoint that you take some data, you wrap it up as JSON, post it to that endpoint, and it's going to give you back, bang, 201 created. And it's going to say location there. So what this has effectively said, you've given me some data, I've accepted it. I have created a resource for you. Here is where you can find that resource. And then as a convenience, we're actually going to include the resource that was just created in the payload and the response to save you having to do a round trip. And this is brilliant. Iron Man goes and tells all his mates about it, and Spider-Man tells all his mates about it, and we get up in the morning, and 2 million people have joined our social network by posting their own stuff in JSON. We've got everyone down as far as Howard the Duck. We've got obscure superheroes no one's ever heard of from that one comic book special edition in 1962. And then the phone rings, and it's the network team, and they're like, your API is using all of our bandwidth. We were doing fine yesterday, and now the entire continent of Australia can't get online because your API is consuming all of it. And someone else says, your stupid API is overloading our database. The reason this is happening is because we've got a resource called profiles, and when there was one person in that list, you could get it, and it was fine. 2, 3, 4, 5 people. 2 million people. Every time anyone goes get profiles, they are retrieving 2 million records. Every time they do it. This is clearly not a terribly good idea because it is going to clobber the bandwidth, it's going to clobber database, it's going to waste an awful lot of resources. We want a more elegant solution to this. So someone comes up with the bright idea, hey, why don't we just do pagination? So we'll split it down into pages, and we'll have page 1, page 2, page 3. And we think, yeah, brilliant, nice idea, okay. So get profiles page 1, bang, there's some stuff. And if you need more than that, you can go in and you can go, okay, get me page 2, page 3, page 4, page 5. This looks pretty simple, it's easy to understand. At this point, we have stopped being RESTful. It works, but it's not REST. The reason it is not REST is that at this point, that knowledge, that understanding that page number starts at 1 and goes 2, 3, 4, 5, that's state. That's understanding the transitions that are available from a particular point in our application. And we have not defined anywhere within our resources how that state exists. To know that we support page 1, 2, 3, 4, 5, you're going to have to look on the wiki or read the manual or file a support ticket or something. And we don't want that because we want our API itself to be explorable. So, anyone recognize these? 1 person, 2 people, 3 people, 4, 5, 6. I grew up on these. These are choose your own adventure books. These are brilliant. So you open page 1 and it outlines this scenario, and then so let's actually have a look. So here's an example. So this is the NDC Sydney Choose Your Own Adventure. It's Tuesday night. You've just arrived in Sydney. You've been traveling for 29 straight hours, and your brain thinks it's 1:30 breakfast time yesterday. You should probably get some sleep. But there's talk of heading downtown to Scruffy Murphy's for drinks. And Niall is going on about this amazing whiskey bar he found down some dodgy back alley. And now we have to make a choice. To go to our room and take a nap, turn to page 74. To go to Scruffy Murphy's for a beer, page 23. And if you want to go and drink single malt with Niall until your Visa card stops working, go to page 41. So show of hands, who's going for a nap? Scruffy Murphy's, whiskey bar. Good choice. This is a really great example of hypermedia, because what we've got here is we have a resource representation in a format that the consumer can understand, and attached to that resource representation, we have all the information we need to understand what can we do from here. What are the options? Where can we go? What avenues of exploration are open to us having retrieved this resource? So let's go back to our endpoint, our profiles endpoint, and let's, instead of using page 1, 2, 3, 4, let's actually put some hypermedia representation in. Now, this particular example, you'll notice the bits in yellow are effectively the things that have changed. So 1, our content type is not JSON anymore. It's HAL plus JSON. The way content types work, the application bit is standard. You can put anything you like before the plus. The bit after the plus is standard. So what we're doing here is we're saying we're going to extend the basic JSON data type with something called HAL, Hypermedia Application Language, which is one of several JavaScript multimedia, hypermedia formats that we'll look at in a second. I like HAL because it's quite compact and it's human readable, and for these kind of examples, it's succinct and it's nice, it works well. So what HAL does is it says, okay, we are going to, the data itself, we're going to wrap up in a collection here called items. And we are going to add a collection called links. Anything in these examples with an underscore is part of the HAL specification. Anything else is my own stuff, things that we've added to demonstrate how this works. So now when we get /profiles, we get this little payload that says, okay, here's where you can go from here. We got a self link. If you want this same thing again, this is the URL you go to. The next page is available here. The last page, we have this wonderful hashing problem in English. The word last can either mean like the one before this one, or it can mean the last one in the list. So I should have fixed this. What I tend to do is I use previous and I use final in systems so that we avoid the word last completely. So we basically said, so the final page here is index 220. There are 5 items in this list. Your list is index 0 in a collection of 223, and here's the stuff you wanted. And this is pretty cool. It's easy. It's readable. You can look at that, and you, or more correctly, your API client can go, all right, let's open the links collection and see if next exists. If it does, we know we're not at the end. When we get to the end of the list, next will come back as it won't even be there. Okay, fine. We've got the entire list. Whether we're storing that locally or caching it or we're just showing it in some kind of a data grid or something, kind of doesn't matter. So that's the first example of using hypermedia to inform clients how they can interact with the system we've got. Now, the nice thing, one of the reasons why hypermedia gives you this flexibility, the client does not have to know that we are doing page 123 or index 0, 5, 10. If we decide that actually we're going to start doing things alphabetically, the client, all the client needs to know is to go into the links collection, find next, and retrieve whatever that is. Next is a convention that's part of our system. Links is a convention that's part of HAL. href is a convention that's part of how hypermedia JSON works, but the URL itself, the client should not know, it should not care. It should retrieve it, it should follow it, it should request the next one. We can switch to doing pagination alphabetically. We can switch to doing it by which shard in our cluster the indexes are stored on. We can do all sorts of things with it without breaking the client application, because the client is following those links instead of having some hard-baked behavior that someone wrote after reading about it on a wiki. So, social network. Let's start with friends. We can look at adding enemies later. So, we got a username, we've got name, we're going to add friends to it. We got username, we got username, we got username, we've got collections of friends. And because this is a social network and you want to be able to stalk people and see what they're doing, we're going to add updates. So, Tony Stark has gone on and he said, hey, I'm working on a new Iron Man suit. And then a little while later, he has this brilliant idea. He's going to build an Iron Man suit with a selfie stick on it, so he can take photographs of himself out saving the world. And then a little while later, he says, oh no, the selfie stick broke. Oh well, back to the drawing board. So we got friends and we got updates, but of course the friends can have updates. And the friends can have friends. And the friends' friends can have updates. This, by the way, is what they call big data. This is when the JSON won't fit on a PowerPoint slide anymore. We have a problem, because the phone is about to ring again. Or, something's going to pop up on HipChat or Slack, and someone is going to say, your stupid API is using all of our bandwidth again, and someone's going to say, your API is overloading the database again. I told you we should have stuck to PHP. We never had these problems with PHP. What we've basically done is we've built a degenerate system, because when you request one person, it's going to bring you back all their friends, and all their updates, and all their friends' friends, and all their friends' friends' friends. And so there is no way to say, please get me one profile, and please do not bring back the entire connected graph for this whole social network. So what we want to do is to break the resource down. Instead of this huge tree that you start at the top and you get the whole thing, it's everything or bust. We're going to use the same hypermedia principle to break this profile down into lots of little granular bits of data. So same thing. HAL JSON, we're getting Iron Man's profile. Links, we got self, we got friends, we got photos, we got updates. So we can retrieve this. And again, we have an API client that goes in there. We need to tell it, this is friends, this is photos, this is updates. Those things ideally won't change. It's part of the contract between our server and our consumers. But the URL formats don't matter. We can move friends onto a whole separate infrastructure. We can do the rest on AWS and friends on Azure if we want to, because the client just knows how to follow the URLs and it doesn't care what those URLs are, because that's the backbone of this kind of hypermedia stuff. And this looks pretty cool. And so now someone's building an API client and they go, yeah, profiles, brilliant. Okay, let's get friends. Okay, let's get updates. Okay, let's get photos. Ooh, yeah. Let's get photo number 1234. Ooh, photo 1234's got some comments. Let's get those. Let's get photo 1345. Oh, and that one's got some comments. Let's get photo 1456. And then this happens. The phone rings again, or Slack, or HipChat, or Twitter, or Skype. And so I was like, dude, your API is crazy. I just want to draw a profile. I got to make like 50 calls. And then your ops team ring up, and they're like, our web server just crashed because the IIS logs have filled up the C drive. You ever had this happen in production? Yeah. Something that used to be one HTTP request is now 50 requests. And every one of those requests is going to write something to C inetpub log files. And they were like, well, of course we put all the applications on the D drive, but we didn't think we had to move the logs because this never happened before. And of course we never had this problem with PHP. So we've gone from massive 2 gigs of data that is dreadful because every time anyone tries to request anything, it overloads the network, to tiny little pieces of data that are overloading the network because you have to make like 50 calls in order to do anything. This is one of the absolute key things where REST doesn't make a whole lot of sense until you know what words to Google. And the magic words to Google are resource expansion. Once you know that that's what you're looking for, you will find a wealth of very good information about how to do this. If you don't know that particular phrase, you can stumble around for ages going, REST API, too many requests, REST API, too slow, log files, and so that's, make a note of that one because that's a really useful kind of shibboleth to know to go and look for more information about this stuff later. But what we're effectively doing is something that's very analogous to the idea of eager loading if you've ever worked with an ORM. It's saying, I want this, but actually I know what page I'm trying to draw, or I know what form I'm trying to populate. I would like to please get Iron Man's profile, and can you bring back the updates inline? Bring back those as well. And so what we've got, this bit is ours. We are free to create this resource expansion however we like in a way that works for our clients and our servers. And Hal basically says, okay, so we're going to find the thing named updates, and then in the embedded payload, we are going to stick in a JSON property called updates, which in this case is effectively what we would have got by making a second request, only it's going to make it for us and insert it into the embedded thing. And you can do some quite sophisticated stuff by supporting dot paths. So you can expand updates.friend.username or update.friend.photo. You can expand updates, comma, friends, comma, photos. It may not necessarily work. It's very, very good to think of this as sort of a hint rather than a guaranteed behavior. Because at some point, you may request so many expanded things that your server, you make a conscious decision, no, if someone asks for all that, we're not going to give them what they wanted. So one pattern that's useful for implementing this is when you request something, cache it locally with the URL of the resource. Remember, we're optimizing here for infinite caching. So once you've got something, stick it in a cache until you run out of memory. And if you need that thing again, the first thing you do is you check your cache. If that doesn't work, you stick it in a resource expansion. If after the resource expansion, the cache is still empty, then you go and you do another request and you actually explicitly fetch that thing. So you have this idea of trying different layers in your architecture to see whether you have a convenient, handy copy of that thing knocking around that you can use. Let's quickly talk you through, there are about half a dozen different hypermedia formats. It's one of the things that when JSON was sort of first postulated, this idea of using JavaScript as a data format instead of as a programming language. One of the things that it doesn't natively have is any notion of hypermedia. So people have extended the language in various ways. I'm going to talk you through these quickly. We're not going to go into a lot of detail. It's just worth knowing what they are if you want to go away and Google this stuff later. JSON LD is the web standard one. This is a W3C standard that's been ratified. JSON LD is very much read-only. It's about navigating collections of data that you're retrieving. Hydra extends JSON LD by telling you interactions and actions that are available on those resources. JSON API is another one which has got a fair bit of traction. Collection plus JSON, Siren, HAL. JSON LD looks like this. So the interesting thing to notice here, this is another one of those things that's a bit confusing until you get it. These are real URLs. There is a consortium of people, including Facebook, Google, Microsoft, Yahoo, Apple, who are basically trying to write a definitive guide to everything of how you represent machine-readable data about real things. And so what we've got here is, if you go there, it will actually explain what a name is in the context of JSON LD. And anyone who implements this should use name to mean the same thing. So in this context, it's this wonderful kind of taxonomic hierarchy. At the top level, it's got a thing. And then a thing can be a person, and a person can be a film director, and a film director can be a something else. And you have this very, very rich hierarchy of interactions and behaviors. But the point is, if you request anything from a JSON LD endpoint that defines a name and an alternate name, you should be able to use those things consistently, both in the way you build your applications and in the discussions you can have about them. So we've got a thing here, which has a name, it's got an alternate name, and it's got an image, and the image has an ID, and the ID has a type. And then down here, we've said, OK, so within the context of this person, the name is Tony Stark. And if you want to know what that means, go and look up here. Alternate name is Iron Man, and that's a URL to an image of this thing. Once you click that schema.org is not like example.com, everything starts making a lot more sense. Hydra, is this legible from the back? I'm aware that there's a fair chunk of code on this, so I won't dwell on it too long. Basically, Hydra extends this by saying, OK, so there is a supported operation here, which will allow you to, it expects a certain schema. This is the method it allows. These are the status codes you can expect to get back from it. And then down here, we document the get, like the read-only interactions that happen with that. Collection JSON, semantically fairly similar to HAL. We've got this idea of a version. We've got an href for the resource we've requested. We've got a collection of links. And then we have a collection of items which sits in the same payload. This has an interesting example in that the items themselves contain a nested links collection to show you how you can have hypermedia at the top level, but you can also have hypermedia relationships with resources that are embedded in the payload of the thing you've just retrieved. JSON API, again, similar solution to the same sort of problem. We've got the same collection of links, self, next, last. And then in here, we've got collections of embedded data types, including relationships. There is some interesting semantics around what things like author and comments mean in the context of this, which is worth reading up on if this is a format you want to use. Siren is another one that allows you to define, as well as defining read-only properties, you can define actions. So what we've got in here is we've got a resource. We got here a mission list. So we got one of our superheroes, and we want to send them off to do something somewhere. Pull a bunch of data out. And here we've got an action. So this is what it's called. Title is interesting because these are human readable. This is designed to be something that you can theoretically render your user interface based entirely on metadata that's been provided in the representation that you've retrieved from the API. So we've got a bunch of fields here that you need in order to send Iron Man off on a mission. You've got a type, you've got an endpoint href, and you've got some human readable commentary going with that. Like I said, there's an awful lot to it. Some of them are very similar, some of them are very different, some of them are standard, some of them are not. If you want to do anything, it's worth doing a quick pass over all of them. One of the things you'll find is a bit dizzying, particularly if you're doing the stuff in .NET, is you've got 5 different JSON hypermedia formats, plus you've got a choice between ASP.NET MVC or Web API or Nancy or OpenRaster or Service Stack. So to pick the right one, you need to look at like 30, 35 different combinations of technologies and stuff, which is why I love working in IT so much. There's just so many standards to choose from. OK, let's enrich our API a little bit. So we're going to go back to profile, and we're going to start adding a whole bunch more data so we can get really, really stalky on people. So we are going to add height, weight, location, status, hometown, email, website, birth date, last modified. We've got all of this rich information, all this great stuff on there. Now we want to go in and update it. So we're going to use an HTTP put. And we are going to put to /profiles, HTTP 1.1. That's our content type. And we're going to update the status. Now, what we don't know is that Iron Man's wearing his Apple Watch, and his Apple Watch is linked into our Heroes network. And as he's flying home across the Atlantic, it is constantly updating his location and posting it to our network. So by the time he's finished composing this update, the location is out of date. So when he tries to do that status, it's going to say 409 conflict. The thing you sent me does not match the thing I've got. Now, this is a problem you'll hit quite often if you are using this idea of just putting a profile. Put in HTTP says, whatever is at this endpoint, whether there's something there or not, replace the whole thing with this new copy. So you have to provide the complete representation of the latest version of that resource, and the server will interpret that. Either it'll just blindly replace it and risk blowing away some data, or it'll do some complicated version checking, authentication. It's up to you how that gets implemented. But the signs that you're getting this wrong are that you start getting these kinds of support requests. Someone's saying, why do I need to put the whole profile just to update location? You know, this is crazy, because we're going to add more and more and more fields to this thing. And someone else is saying, every time I try and do an update, I get a 4 and 9 conflict, because I can't actually retrieve, update, and post back fast enough to keep up with the changes that are being pushed through the system. So there is one solution we can apply to this, and that's to break our resource down into lots of tiny little endpoints. So instead of Iron Man's profile being a resource, we'll say, well, what about if the status element of that profile was a resource? And then we could put that on its own. So we're going to put to profiles Iron Man status, finished saving the world, I need a drink, and it's going to say 204 no content, which basically means I got this. Cool, sorted, fine. This works. You will very quickly find that you have got dozens of tiny little resource endpoints, which are all gettable and puttable. And then you start getting into all the complicated semantics, because now you've got all of these different resources. You need a way of navigating them, so you end up with very, very complicated links collections and stuff. What we want is a better way of changing one element of a composite resource. Patch. This is from the RFC specification, RFC 5789, which tells us how to implement patch. Except it doesn't. It tells us that patch is a way of doing this, but it doesn't actually provide very much guidance at all on how you should go about implementing it. Patch method requests that a set of changes described in a request be applied to the resource. The set of changes is represented in a format called a patch document identified by a media type. So far, so good. This is the actual example from the RFC of how you implement it. That's what they tell you. This is how you submit a patch, which is great, because it means we are free to do this however we like. So one completely standards compliant implementation of patch is that we download the profile, we update it in our favorite text editor, we save it, we use the Unix diff command to diff the old thing and the new thing and spit out a patch file, and then we upload the patch file using patch with this custom content type of application x Unix diff. We upload the patch, and the server goes, great, I'm going to take that, and I'm going to use the patch command to apply it to the resource, and yeah, everyone's fine, happy. 200, okay. There are better ways of doing it. There is a thing called JSON patch, which is a format for representing a series of changes. It also includes some fairly neat stuff around operators. So JSON patch effectively gives you an array, so it is an ordered list of operations. So in this example, what we're saying is, first of all, we've got an HTTP if match header. So we've got something that will generate checksums and make sure that the checksum the client's seen most recently is the same as the one on the server. Then, for a bit of extra resiliency, we're going to run an operation called test. We are going to go into this profiles Iron Man, which is a JSON resource, and we are going to find the thing which is at last modified in that resource, and we are going to test that it is equal to this. If it is, we are going to proceed to the next operation in the list. If it is not, we are going to return a 409 conflict and bail out. The next thing in the list is a replace operation. We're going to find the thing at status, and we're going to say, finished saving the world, I need a drink. 200, okay. Or we could decide that we are going to implement patch using memes of Nicolas Cage, which is completely legitimate. There's nothing about this that defies the standard. You know, we have a thing that if you want us to do something, update your record, update your email address, you have to go to memegenerator.net and put it on a JPEG of Nick Cage, and then you've got to upload that as a Nick Cage plus PNG. And what we're going to do is we're going to print all those out and stick them on someone's desk, and we're going to return 202 accepted, which is seriously old school, but is still actually standards compliant. There was an interesting thing in Scott's keynote this morning where he was talking about guys at Intel who have to send a fax to provision you virtual machines. I was thinking you could actually probably implement REST or RESTful systems using fax machines, as long as you controlled what it was that was written on the fax and what response you could realistically expect. Because a 202 accepted is a kind of general purpose, we are going to deal with this later. Come back, try again, or we'll notify you, or start polling every 10 seconds to see if this thing's ready yet. So you could probably implement REST using fax machines. I wouldn't recommend it, but it'd be fun to try. If they can do HTTP over carrier pigeons, we can do this. So CEO comes down, and he's like, someone they're looking to buy our network, and they need to make a couple of changes to our data format. We need to expose forenames and surnames separately so that we can index by surname so that they can feed it into their CRM system. And also they want to replace the hometown with an ISO 3166 country code so we can do that cool Google Maps visualization of where all our users are. And it's Friday, it's kind of late, so we sit down and yeah, no problem. So we just go in and we change the JSON format and we break this up and we break hometown down into a city and a country code. And then we push straight to production because it's late and what the hell, integration tests are probably all right, maybe. And then when we log on later, we have a string of messages saying, hey, your API has broken our application and our website stopped working and none of our reports work and you broke the internet. Oops. We did. We made a breaking change. We changed our format such that the clients that are out there that are expecting name to be one field are suddenly finding a chunk of JSON. The best thing that's going to happen is they're going to just treat that JSON as a string, and suddenly all our customers are going to be called open brackets, first name colon, Tony, comma, surname colon, start, close brackets. They're more likely to crash catastrophically, and they're going to do this on every single resource because we've changed the fundamental kind of root level profile entry. So we need a way of being able to make those kinds of changes without disrupting people who are already using them. Easiest thing to do is never break anything. Just get it all right first time. So have a big design meeting and write down all the answers for the next 20 years, because REST is software design on a scale of decades. You might be able to get away with not breaking anything for a couple of months, but seriously, if you're building systems that are going to run for any serious length of time, things are going to change. And there are solutions to this. And the interesting thing there is, how do you decide which solution to adopt? Because they are all wrong. There are three ways. So a lot of this stuff is, Troy Hunt wrote a great blog post on this 2 years ago now, where on his Have I Been Pwned thing, he was rolling out version 2 of some APIs for that, and he did this great write-up of the different patterns. And there's some, Sebastian Lambler is out there right now giving talks about don't version your APIs, it's evil, you should do everything using content negotiation, which is kind of a different approach to versioning. So there's a lot of interesting thinking around this. So one way of doing it is that you have a version 1 API and a version 2 API, and they're on different URLs. So get version 2, OK. Get version 1, OK. This requires you to know when you do version 1 that there's going to be a version 2, so you can put version 1 in the URL. So it doesn't downgrade particularly gracefully. Another way of doing it is to use content negotiation. So when your client connects to your server, the first version probably says, hey, I speak JSON, just give me JSON. And then you realize that actually you need to do something a little bit more clever. So what you can do now is you can say, I'm going to define a custom MIME type, application vendor.myapi.version2 plus JSON, or vendor.myapi version 2 plus HAL plus JSON. Now the nice thing about this is if you forgot to do anything special in version 1 of your client, your server can go, right, anyone who asks for JSON, we know that they're version 1. Because if they were version 2, they'd know that we changed this thing. So anyone asking for version 2, version 3, version 4, you can handle that with content negotiation. And again, same thing, spits back at 200 OK. The third approach you can take here is you put a custom header in, and you just say, get me application JSON. And by the way, X my API version, I'm running version 2 today. What are you running? How do you decide? And this, is another, all of these approaches work. It all hinges on whether version 1 and version 2 are the same resource or not. If you imagine we've got a photograph in our archive, so we've got a picture of the Opera House and Sydney Harbour Bridge, and one client requests that picture as a PNG, another client requests it as a JPEG. It's pretty obvious there that what we're doing is we're taking the same resource and we're just using a different representation in each of those scenarios. Whereas you may have a scenario where customer version 1 is a completely different set of data. Your version 2, you rolled out all sorts of compliance. You started doing deliveries to the door, so suddenly you've got street addresses. You're indexing people by social security number instead of by database ID. It's a business decision. You need to understand your domain and how you are modeling your domain well enough to know whether version 1 and version 2 is analogous to the same photograph as a TIFF or a JPEG, or whether version 1, version 2 are actually different representations. Because at the end of the stack, there's probably a real person who hasn't changed. It's about what properties of that person are being modeled in your system and whether you've changed that enough that it's actually a completely different resource. So if version 1 and version 2 represent same person, same resource, use content negotiation. Same thing, different format. If they're completely different, it makes sense to use a different URI. Because in this case, you have different resources. A resource should be addressable by the same URI. So different resource, different URL. Kind of makes sense. Or there's actually, this is the point where REST is not the right solution for our problem. We'll just use a custom header. It works. There are lots of very successful systems that use this approach. So that's how you handle it on the client. But what do you do on your server? Suddenly you've got an API that needs to be running version 1 side by side with version 2. Do you branch your code base and have separate deployment pipelines for V1 and V2? Or do you stick with one code base and you do all the content negotiation in code and you have, like version 2 of your controller inherits from version 1 of your controller and this kind of stuff? This is about the only question I've ever come across in computer science where the answer is not, it depends. I think there is actually a right answer to this. And the right answer is that you use one code base. You have one deployment pipeline. You have one set of tests. You have one single, base of code that represents every API version that you are still running in production. And you use something akin to this, because all of these approaches you can actually map onto the same chunk of code. So what we've got here is a web API example where we've got a getV2 method. We've got an attribute here that says if the client is negotiating on content type and giving us version 2, you should hit this one. And we've got a naive route saying API/v2/profile/name comes here. And this stuff is actually pretty easy. And the nice thing about it is you can monitor the routes that are being hit. And when you realize that no one is hitting version 1 anymore, you can go in and you can just remove it from that element of the code base. The stuff which is common to version 1 and version 2 doesn't end up being 2 copies of the same module deployed to 2 different places by 2 different pipelines. OK, so next bright idea from your chief executive officer. Someone comes in and says, hey, we hired the CFO's teenage son to build us a mobile app. Because, and he's like, yeah, can I get in the database? Because I need all the customer data so I can build this mobile app using a mobile app building toolkit that I found in my summer holidays. And someone else is like, hey, we just found out that linkbait.com is asking users to put their password into their website so they can log in and scrape all of their friends from our network. These are real scenarios. These are the kind of things you come across all the time. You've got all this data, and other people want to use that data to do things. And your users maybe have a completely legitimate reason for wanting to share that, or your users are being misled, they're being phished, they're being misinformed. How do you go in and implement the sort of security which will protect users' data while still offering them control over who can do that and what? Now, conventionally, there's always been this approach to think of security very much like, if you imagine a bank, there's a set of doors, and then there's a public foyer, and then there's a counter, and behind that there are the tellers, and behind that there's a manager's office, and behind that there's a vault. And some people are allowed in the vault, and some people are allowed here. It's this very, very kind of atomic level of security. Either we trust you or we don't. And if we trust you with everything. I've worked on systems where there's a flag on a user that says, do they have delete access? And if they do, it means they can delete anything in the entire system. And if they don't, they can't delete anything at all. Which kind of works when you're dealing with a small number of trusted employees, but for building large-scale distributed systems where there maybe isn't a hard line between who's an employee, who's an administrator, who's a customer, who's a user, you need to take a much more granular atomic approach to the way you think about security. You don't want this idea of there's a bank vault and you're allowed in and you're not. You want something more akin to you can get into your safe deposit box. You can get into yours. You can get into yours. You can use yours. You can't get into anyone else's. Now, the protocol that exists for facilitating this is something called OAuth 2. So OAuth 2 is an authorization protocol. It's not an identification protocol. There is now a thing called OpenID Connect that sits on top of that. If you're interested in building this kind of stuff, don't, because nobody builds their own crypto systems and no one should build their own authentication. Download Identity Server, work out how it works, and use that, because that solves all of the hard problems to do with the cryptographic validity of the underlying protocols. It's a very nice platform. It's very extensible. But effectively what OAuth 2 does, so this is our end user. We've got linkbait.com, and we've got us. We're startup.com. This is our website. This is our API. And Linkbait wants some data from our API. And the user is happy for this to happen because the user thinks linkbait.com is brilliant, and they want to tell all their friends about it. So the first thing that happens, the user goes to Linkbait and says, hey, it's me. And Linkbait goes, prove it. Go to startup.com and tell them we are allowed access to your stuff. User gets redirected to startup. They log in there. We validate them. We send them back a page, prove that you're you. They put in their credentials. Credentials have not been shared with Linkbait. The credential flow is between the customer and us. We say, yep, gotcha. We give them a token in the browser redirect and say, go back to linkbait.com, give them this. Don't give them your password. That would be crazy. Give them this token. It's actually a pair of tokens. A thing called an access token and a thing called a refresh token. The customer gives that token to Linkbait. Linkbait sends the token to our website, says, is this real? Now, what it's doing at this point is it's taking the refresh token, or it's taking the code exchange token, and it's saying, hey, the customer just gave me this. Can I have some keys, please? And our site is going to respond with, yeah, here you go. Have a set of keys. They can then use those keys to go onto our API, pull data off it. Data goes back to linkbait.com. Linkbait sends that back to the end user. Everyone's happy. The best way to think of this token exchange, so the key thing about these two keys, there's an access key and there's a refresh key. The access key is like a safe deposit key made out of ice. You can use it unsupervised for about 10 minutes, and after that it stops working. Now this gives you very powerful scalability because you don't have to validate every single request. You pick a time window and you say, well, how much damage can someone do with a key that we know is going to work for 10 minutes, but after that it's never going to work again? Because an access key can't be revoked. If you're doing stuff with financial systems or anything really important, there are ways of doing per request key validation, which are extensions to the protocol. But the underlying principle is, we'll give you a key that'll last for 5 minutes, 10 minutes, that'll let you make as many API calls as you want, and then it'll stop working. And when it stops working, you take the refresh token, and you go back to us, and you say, give me another access token. And assuming that the customer has not logged in and gone, settings, applications, revoke, that refresh token will succeed. We'll give them another one of these little melty ice keys that'll work for another 10 minutes, and another 10 minutes, and another 10 minutes. At no point are the customer's credentials shared with the third party, and beyond that 10-minute expiry window on the access token, there's no risk to the customer that their data is going to be exploited by Linkbait in a way that our startup provider can't control. So that's OAuth 2, OpenID Connect. We looked at content negotiation. We've looked at API versioning. We've looked at resource expansion. Hopefully, all of that stuff, A, has been interesting and informative. B, has helped some of you maybe understand a little bit more about what REST is good at and when REST might not necessarily be the right answer. We are nearly out of time. We have a couple of minutes for questions. Are there any questions? There is a question. Hang on a sec. There's a microphone coming around.
Oh, I can talk pretty loud anyway.
Yeah, but it's for the recording.
In your list of hypermedia style frameworks that are available, did
Yes.
I see JSON API or Open API? Or
JSON API.
So the question is, does Open API, which is ex-Swagger, count in your list?
Probably. I'm not familiar with it, so I don't know. There is a lot of very, very active development going on around a lot of these formats. Open API isn't one I'm familiar with. Swagger I have come across. So Swagger is basically a way of, it's almost an API design language, isn't it? It's a way of defining your endpoints, what they support. The nice thing about Swagger is that you can take a Swagger definition, you can generate documentation from it, you can generate dummy clients from it, and you can generate dummy servers from it. Because one of the nice things about that kind of API thing is you can design the thing, and then you can spin up a dummy implementation that your front-end team can start calling. And also a service stack, which is one of the .NET frameworks, will actually generate the other way around. You can generate Swagger documentation directly from the metadata, and then you can generate nice HTML docs from the Swagger. So Swagger is another good one. It's worth looking at. But in terms of open API, I don't know.
That's what Swagger has become.
Ah, so yeah, probably then. I don't know if there's anything in there that's intrinsically related to hypermedia, but I'll certainly go and look it up. So, any other questions? Yes.
For the versioning thing, how do you actually define a version for an API? Like if an API has, say, representing like 3 different resources today.
Yep.
So it's possible that I add a new resource tomorrow.
Yep.
Or just one of the resources has changed properties or something like that. So is the entire API versioned, or is just like the profile that is versioned, but the friends are not versioned? And so how do you do that?
The canonical way of doing this is that somebody is retrieving /profile, and one morning they look at the links collection, and in links collection there is an href for version 2 of that profile. Hypermedia is an incredibly flexible pattern that you can use for all sorts of things. And as well as saying, hey, this profile's got friends, this profile's got status updates, you can say, this profile has a newer API representation available. So you can use the same hypermedia patterns. And the thing about that is because you're not changing anything, because you're just adding new fields to it, you won't break clients by adding new elements to the links collection that's available on a resource. And so that gives you a way of gracefully notifying clients that a new representation of something is available. It's also an argument in favor of doing sort of either content negotiation style stuff as opposed to just saying there is now version 2 of our API, which completely deprecates version 1. You can actually go with the idea of having versioned resources which conform to content negotiation instead of saying, hey, where it said v1 in all your web addresses before, put v2 in there now. Does that answer the question?
Partly. That's fine. I mean, the other thing is that's more of a, I guess, a discussion is, have you seen a resistance to do this proper way of REST? Because I have the huge amount of resistance from, let's say I'm doing an API. My clients didn't want all these things. They said they're all crap. I don't need these things bloating it. I have no reason for all these links, href, blah, blah, blah. They just rejected this concept. They wanted to go to page equal to 5.
Yeah.
The clients didn't want it.
Are they paying you?
Well, it's my own company, so they're all working together, but they didn't want the API people to give them APIs like that. So we couldn't do the rest of REST.
You can try and educate them, or you can accept that they're paying the bills and you do what they want. It's the great trade-off of anyone who goes, we don't like your solution, you know. I don't have a magic bullet answer for that, you know. I think understand it, understand the costs, understand the trade-offs, and then try and reach an informed consensus among the people who have a stake in the thing. So, any other questions? Grand. Well, thank you very, very much for coming along, taking the time to listen. My name's Dylan. I'm on Twitter as Dylan Beattie. I'm on email, dylan@dylanbeattie.net, if any of you want to follow up on anything or talk about any of this stuff further. I'm around all week. I'm the one wearing a big, stupid cowboy hat, so come and say hello if you have any more questions or anything you want to talk about. Thank you very much. Enjoy the rest of the conference.